Today we are going to discuss object relationships, and the topics which fall under this are relationships between classes, association of objects, type of association, recursive association, multiplicities, navigability, name association, aggregation of objects, type of aggregation, delegation, modeling association, and aggregation. Relationships between classes. We know that in real world everything and anything is represented in terms of objects, and we discussed in the last unit that anything and everything which can be represented in terms of state and behavior can be represented as a object, and the group of such objects do form a instance called class. Now we are going to study the relationships between one class to another class and objects of a same class, and followed by objects to object relationships. When you build abstractions, you will discover that very few of your classes stand alone, whereas many of the classes are interrelated to each other classes. Most of them collaborate with others in the number of ways. Therefore, when you model a system, not only must you identify the things that form a system, but also must model how these things stand in relation to one another. In object-oriented modeling, there are three kinds of relationships that are especially important. Dependencies, which represents using relationships among classes, including refinement, trace, or bind relationships. Generalizations, which link generalized classes to their specialized classes. For example, base class, subclass, or superclass, child class. Associations, which represent structural relationships among objects. Each of these relationships provide a different way of combining your abstractions. We'll take a simple example. If you are building a house, things like walls, doors, windows, cabinets, and lights will form part of your system. None of these things stand alone. However, walls connect to other walls, doors and windows are placed in walls to form opening for people and for the light. Cabinets and lights are physically attached to walls and ceilings. You group walls, doors, windows, cabinets, and lights together to form higher level things like rooms. Similarly, in UML modeling, that is Unified Modeling Language, the ways that things can connect to one another either logically or physically, and they are modeled as relationships. In object-oriented modeling, the three relationship types are dependencies, generalizations, and associations. Dependencies are using relationships. For example, pipes depends on water heater to heat the water they carry. Generalizations cannot connect generalized classes to more specialized ones in what is known as subclass, superclass, or child-parent relationships. For example, a bay window is a kind of window with large fixed panes, whereas patio window is a kind of window with panes that open side by side. Associations are structured relationships among instances. That is, dependencies and generalizations are explaining the relationship between the class to class, where associations are structured relationships which are among object to object. For example, rooms consist of walls and other things. Walls themselves may have embedded doors and windows. Pipes may pass through walls. In this example, window, the different operations can be performed on the window are open, close, move, display, handle event. Here, the handle event function is directly dependent on the event type which is going to occur. Therefore, the dotted lines with arrow head indicates a dependency type. Next, there are two types of windows exist. One is console window, other is dialog box. And we can easily say that console window and the dialog box are the subclasses of a main class called window. Therefore, we can easily categorize that window is a superclass and console window and dialog window are subclasses or generalizations. Dialog box and control. Here, control is a instance which occurs based on the appearance of the dialog box type. Here it is an association type with a thick straight line.